Hi everyone, let's do the classic problem. Given two distinct points in the xy plane, find the slope-intercept form of the equation of the line that passes through the 2 points. -4, 5, and 2, -6. Let's plot them here. -4, 5, and 2, -6. All right. Okay. So I want to find the equation of the line that connects these 2 points. Imagine I'm playing a video game. How did I get this guy to shoot at this guy? I'm playing a video game. Okay, let's find the slope-intercept form for the equation of that line. This line has many equations we can attach to it. I want this form. Well, it would help if I found the slope, right? Slope is rise over run. So it's change in what over change in what? It's change in y over change in x. It's rise over run. Okay, the slope is delta y over delta x. Please remember not to flip these. That's a very, very common error. I'll put this in red. Do not switch these. Capital. Do not switch these, because it's an extremely common error in exams that people put the delta x on top just because they're thinking alphabetically. Remember, slope is rise over run. It's change in y over change in x. Now, you can take the difference in either order. You can either go -6 minus 5 or vice versa, but be consistent. Whatever order you go in on the top, you better match that order in the bottom. If you go -6 minus 5 on the top, that's fine, but that means that you have to go 2 minus -4 on the bottom. If you do it in reverse, you're going to mess up your sign. All right, so in the end, we have, well, the rise, -6 minus 5 is -11, over the run is going to be 2 minus -4. 2 plus 4 is 6. So you could say that if the run is 6, then the rise is -11. Really, it's a drop of 11. The slope is -11.6. By convention, we normally pop out that -1 factor out here. The slope is -11.6. So on Desmos, I could say I know y equals, I know y equals -11/6 times x plus something. All right, and then maybe with a slider, I can kind of figure it out. And there you go, that's an approximation. Okay, b is about -2.3, but let's get it exactly, all right? Let's play the video game exactly. But we think b is going to be about -2.3. Desmos is no fair. Don't just appeal to Desmos on your homework. Okay, you can play with Desmos, but don't say in your homework, oh, I use Desmos. Okay, all right, anyway, the slope is -11.6. Now, I want slope-intercept form, but in the meantime, I have the slope and I have 2 points. I have an abundance of riches. I can pick either of these 2 points and write out a point-slope form for the equation of the line. Again, I could use either of these 2 points or whatever other point I happen to find on the line, and I can use this slope. All right. What is the point-slope form? It goes, all right, y minus y sub 1 equals m, the slope, times the quantity x minus x sub 1. And I'm choosing to use the first point, -4, 5. Now again, be careful. The -4 goes in here. It's the x-coordinate x sub 1. The 5 goes over here on the left in the y sub 1. Again, a lot of people switch these up. The slope, we already found that. The slope was -11.6. All right, so then we get y minus 5 equals -11.6 times the quantity x minus -4. And that would count as point-slope form. Now, for some homework problems, that might be enough if I just wanted an equation for the line. Well, I can go into Desmos, for example. Y minus 5 equals -11.6 times the quantity x plus 4, or x, no, x minus negative 4, or x plus 4. Okay, and that's going to be the line exactly. But that's in point slope form. In the homework or in the problem here, I'm asking for slope-intercept form. So now it's a matter of mechanical algebra. How do I get from here to slope-intercept form? Which is y equals mx plus b. Okay, let's do some cranking here. First of all, x minus negative 4, that's x plus 4. Cleaning up the signs there. Okay, and while we're at it, I have y minus 5 on the left. In the end, I want y all alone. So why don't we go ahead and add 5 to both sides? Don't say move, say add. We're going to add 5 to both sides. So then we get y all alone, negative 11/6 times the quantity x plus 4, all plus 5. And now we can distribute. Again, our goal is to find something of the form y equals mx plus b. All right, let's take the negative 11/6 and use what d word? Let's distribute that over the sum. Negative 11/6 times x is negative 11/6. That's easy. The hard part is, what's negative 11/6 times 4? Or more simply, 4 over 1. That might be easier. 4 over 1. In fact, we can do some cross-canceling. 4 divided by 2 is 2. 6 divided by 2 is 3. We're allowed to do this kind of cross-canceling. So in the end, we get negative 11 times 2 is 22. 3 times 1 is 3. In the end, we can reduce by dividing the top and the bottom by 2 anyway. We may as well do it while these factors are separated like that. We may as well divide the 4 here by 2. We may as well divide the 6 down here by 2. In any case, negative 11/6 times 4 will be negative 22/3. All right, this is negative 22/3. Now, in order to add the 5, I like to get this in terms of thirds. 5 over 1 is what over 3? Well, 1 times 3 is 3, and 5 times 3 is 15. I'm basically taking 5 as 5 over 1. I'm multiplying by 3 over 3, or 1, and I'm getting 15/3. That's this over here. All right. Now, what is negative 22/3 plus 15/3? It's like a weird Vegas game. You lose 22/3, you win 15/3, you still lose 7/3. But look at this. Y equals negative 11/6 minus 7/3. I have slope-intercept form. I mean, yeah, you could write this as plus negative 7/3, but minus 7/3, I'm happy with that. Y equals negative 11/6x minus 7/3. That's slope-intercept form. We knew the slope was negative 11/6. What do we know now? The y-intercept is at 0, negative 7/3. All right, so I want the line y equals negative 11/6. I'll put the right arrow, right? Parenthesis x, b equals negative 7/3. There you go. That blue line does a perfect job. And here's the y-intercept, 0, and there's the decimal approximation of negative 7/3. Perfect. This blue line is perfect. Slope-intercept form is unique. So if you write down the slope-intercept form, your friend writes down the slope-intercept form, you better get the exact same thing. Well, your friend, if your friend's a stickler, instead of negative 7/3, you could do this, but I think this is overkill. But aside from that, your friend better get what you get over here. Slope-intercept form is unique for a given line, a given slanted line. But what about point slope form? Was that unique? The answer is no. For one thing, instead of negative 4, 5, I could have used this other point, 2 comma negative 6, which, by the way, would have led me to the same slope-intercept form as well. Or for that matter, you could use any other point, any of the infinitely many other points that happen to be on the line. Okay. I call that method 1. We're going to go to method 2 and show you a faster way of doing this next time.